Hey, welcome to Shark Finger. It's Shadow here, and today I'll be showing you some improvements you can make to your first-person controller. Now, I will be using the basic first-person controller I made in another video as a starting point, so I suggest you check that video out if you need help making one. Now, let's get started. Sometimes you want the player to be able to move faster than normal. Most games limit how long the player can sprint for, while others let the player run around as much as they want. It all depends on the game you're making. As you can see in the video playing right now, the character moves slower when I am just moving, and moves faster when I hold shift and move them. We do this by multiplying our movement speed when our sprint input is pressed. I will also be showing how to put a limit on so the player cannot sprint forever. Also, I will be showing you how to change the camera's FOV, or field of view, to make it seem like the player is moving faster than they actually are. We start by creating an input action for sprinting, so we go to Project Settings, Input Map, add a new action called Sprint, and bind the Shift key to it. Now in the player script, we need a variable to store our initial move speed in, so take this speed variable and make the S a capital S. Then we need a value for the maximum stamina we can have. Export public float max stamina. After that, we create variables to store our current move speed and our current stamina value. Private float speed, private float stamina. We also need a way to know whether the player has run out of stamina when it is refilling. Private bool exhausted. Inside of our ready function, we set our initial stamina value with stamina equals max stamina. Now inside of physics process, we check if the player wants to sprint and we have not been exhausted. If both of these are true, then we make the player move faster and constantly subtract stamina. If input.isActionPressed sprint and not exhausted, stamina minus equals float delta, and speed equals speed times 2. We also want to gradually increase our camera's FOV to a higher value, making the player feel like they are moving even faster. I will be using an extra high value, like 100, to make this effect much more apparent, but feel free to tweak it until it feels just right for you. Float diff equals, in parentheses, 100 minus camera.fov times 10 times float delta. Camera.fov plus equals diff. Then, we need to check if the player has run out of stamina while running. If stamina is less than or equal to 0, exhausted equals true. Now, if the player doesn't want to run or is exhausted and can't run, we need to move at our normal speed and gradually reset our camera's FOV back to a normal value. Else, stamina plus equals float delta, speed equals speed, float diff equals, in parentheses, 75 minus camera.fov times 10 times float delta, camera.fov plus equals diff. Finally, we need to reset our exhausted value if the player's stamina is fully recovered, and cap our stamina so it never exceeds our max stamina. If exhausted and stamina is greater than or equal to max stamina, exhausted equals false. If stamina is greater than max stamina, stamina equals max stamina. Now save the script and rebuild the project using this hammer button in Godot. The speed value in the inspector should be reset, so let's set it to 2.5 again. Then we want to set our max stamina to a value that allows us to sprint for a while. I'll set mine to 10, allowing the player to sprint up to 10 seconds straight. Finally, save the scene and run it, and you should be able to sprint. Sometimes in a first-person game, you want the player to be able to hide behind a short object, or to be able to squeeze through a hole shorter than they normally are. To do this, they give the player the ability to crouch down. We will do this by watching an input. When that input is pressed, we will gradually lower the player's height to a lower value, and when it is released, we will gradually raise their height back to normal. First, we go back to the input map and add a crouch action, then bind it to left control. Back in the script, we first need a way to tell whether we are crouching down, standing up, or not doing either. So let's create two variables, private bool standing and private bool crouching. Now we need references to the mesh and collider so we can change their height as we go. This will only work if the player uses a collision shape 3D node with its shape set to capsule, so make sure that's how you have it set up. I will also show you a method to reference nodes purely in code instead of having to drag them to a slot in the inspector. Private capsule mesh, private capsule shape 3D collider. Next, we need a variable to store our current height in, private float height. Inside of ready, we reference our mesh and collider, as well as set our initial height. Mesh equals capsule mesh, mesh instance 3D, getChild0.mesh. Collider equals capsule shape 3D, collision shape 3D, getChild1.shape. Height equals 2. Make sure you get all of those parentheses correct, by the way. Now, inside of physics process, we change this if statement to an else if statement and have our movement speed when crouching. If input.isActionPressed crouch, stamina plus equals float delta, speed equals speed divided by 2, var diff equals inside parentheses 75 minus camera.fov times 10 times float delta, camera.fov plus equals diff. After that, we go below move and slide and update our height if we are standing up or crouching down. If standing, float diff equals inside parentheses 2 minus height times 10 times float delta, height plus equals diff. If height is greater than or equal to 1.9f, height equals 2, standing equals false, mesh.height equals height, collider.height equals height, position plus equals new vector 3, 0 diff 0. Else if crouching, float diff equals inside parentheses 1 minus height times 10 times float delta, height plus equals diff. If height is less than or equal to 1.1f, height equals 1, crouching equals false, mesh.height equals height, collider.height equals height. Finally, we start crouching when the input is pressed and start standing when the input is released. So inside of input, we write else if add event.isActionPressed crouch, crouching equals true, standing equals false. Else if add event.isActionReleased crouch, standing equals true, crouching equals false. Now save the script and run the game. You should be able to crouch and stand back up now. However, you may notice that if you look down while crouching, you can see the top of the mesh, which doesn't look great. To fix that, select the mesh instance inside of the character, go to the Geometry tab, and change the Cast Shadows option to Shadows Only. Now the mesh will be invisible, but still cast shadows as if it was visible. One very important feature of a character controller, be it first person or third person, is the ability to step up stairs. This can be done by making all of the colliders use a ramp for all steps, but that leaves more work in level design when it could arguably be handled better in code. Here, I'll show you a basic way to handle stair stepping that allows you to set a maximum height the player can step up, allowing them to step up any vertical surface that is lower than that max height. I will also keep it basic to encourage you to find and learn ways to improve it on your own, one such way being smoothing the camera between steps. Anyways, let's get into how to set that up. Back in the script, we need a variable to store how high of a step we can climb. Export public float max step height. Then we want to separate the stair stepping logic into its own function, so right above move and slide, we call a step function and pass it our input direction. Now at the bottom of the script, we define the function with private void step vector2 dir. Then we check if we are moving and if we are colliding with a wall. If dir does not equal vector2.0 and is on wall. Next, we get the point where the character is colliding with the wall and check the vertical distance of that point to the bottom of our character. If the step is too tall, we ignore it. We also ignore it if it is a rigid body, as it seems to cause problems. Otherwise, we move the character up by the height of the step. Vector3 collision point equals getLastSlideCollision.getPosition, collision point plus equals height divided by 2, float dist equals collision point.y minus global position.y. If dist is less than or equal to max step height, and not getLastSlideCollision.getCollider as rigidBody 3D. Position plus equals new vector3 0 dist 0. Now save the script and rebuild the project. Back in the inspector, we want to set our max step height to 0.5. Now save the scene and try walking into obstacles. You should see that you won't move up objects that are too tall or that are rigid bodies, but if they are short enough, you will move up them no problem. The last thing I will show you how to add to your controller is the ability to interact with rigid bodies, allowing the player to push them around by walking into them. Now you could do this by messing with collision layers, but I personally don't like how that tends to feel. Instead, I will show you a method to do this in code using a physics equation for inelastic collisions. Back in the script, we need a value for the mass of our character. Export public float mass. We want to separate this code into a different function and call it constantly, so right above move and slide we call it with collision. Now we define the function at the bottom of the script with private void collision. Next we loop through all of the nodes the character is in contact with and check if they are rigid bodies. For int I equals 0, I is less than getSlideCollisionCount, I++, kinematic collision 3D col equals getSlideCollision I, if col.getCollider is rigidBody 3D RB. Now we plug in the values into the formula, rewritten to work in code as multiple steps, and define the velocity we want to apply to the rigid body. Vector3 energy equals 0.5f times mass times velocity times velocity. Float m equals mass plus rb.mass, all divided by 2. Vector3v equals vector3.0, energy divided by equals m. v.x equals mathf.square root energy.x, v.y equals mathf.square root energy.y, vz equals mathf.square root energy.z. Finally, we apply this velocity to the rigid body with rb.linearVelocity equals negative col.getNormal times v. Then save the script and rebuild the project. In the inspector, we will set our mass to 1 for now. Now save and run the game and you should be able to push rigid bodies around by moving into them. Anyways, thanks for watching and have a good rest of your day.